Sorting Techniques by Brandon Hua. Sorting algorithms in software are designed to arrange elements in a specific order, whether it be ascending, descending, or alphabetical order. Their purpose is to organize data so that it becomes easier to search and manage. There are a wide variety of sorting algorithms, each with their own different way to sort a list, efficiency, stability, and suitability for different data sets. However, in this video we will only cover two, the bubble sort and insertion sort. We will investigate how each technique sorts a list, then compare the benefits and the differences between the two sorting methods. First up is the bubble sort method. It is one of the most simple methods to sort through a list. It works by swapping adjacent elements if they are in the wrong order, with the largest numbers being bubbled towards the end of the list, hence why it is called a bubble sort. At the end of each pass, we will move back to the start and repeat the process until eventually no swaps will be required, indicating that the list has been sorted. Sorted numbers will be colored in green. Here is the list we'll be working with for the bubble sort. As we can see, 6 is bigger than 3, so we swap them. Six is bigger than 0, so we swap them. Six is bigger than 5, so we swap them. Six is bigger than 1, so we swap them. We now have our first sorted number of 6. The algorithm is quite self-explanatory and simple, so I will let the rest of the algorithm play out. After 4 passes of the bubble sort algorithm, we have our sorted array. Our second sorting algorithm will be the insertion sort. It is one of the most simple methods to sort through a list. It divides the array into a sorted partition and an unsorted partition, iterating through the unsorted partition and inserting elements into the correct position of the sorted partition. In the following demonstration, we will work left to right, examining each item and comparing it to the items on the left, then inserting the item into the correct position in the array. The sorted partition will be colored green. Here is the list we will be working with for the insertion sort. We start at 2, and since there are no elements to the left of 2, we consider it sorted. Moving on to 8, we compare it to 2. Since 8 is larger than 2, we leave it where it is and consider it sorted. Next is 5, and we can see that it is out of place. We know it should be after 2, so we swap it with 8. Now our first 3 elements are sorted. Now looking at 3, we can see that it is out of place, so we swap it with 8 and 5 until it is in the correct position. Now, after the swap, our first 4 elements are sorted. Looking at 9, it is obvious that it is already in the correct position. We are now done with our insertion sort. Now we will discuss the similarities and differences between both bubble and insertion sort. First off, the similarities. Both bubble and insertion sort have the same worst time complexity of big O n squared. They are both simple to understand and implement. Both are not suitable for large data sets. Both are stable algorithms, and they both have low memory overhead. Secondly, the differences. Insertion sort builds sorted arrays by inserting elements, whilst bubble sort compares adjacent elements and swaps them. On average, insertion sort performs better because there are less comparisons and swaps. Insertion can be more efficient when an array is partially sorted or has a small number of elements. However, bubble sort is better when the array is nearly sorted.